Okay, lesson 2.1, Introduction to Exponential Equation. Learning objective for today, students will create exponential graphs and tables using Desmos. All right. So first of all, we're going to start off with a little warm-up just to see what you guys remember. Here it says an equation below, and then answer the following questions that are below here. So I'm going to give you guys a couple of seconds just to go ahead and try to answer those to the best of your ability. Okay, so first of all, we have this equation here, and in our last lesson, or in our last unit, we know that we can very easily graph any type of equation that we want to. Okay, so I'm going to go here to Desmos, and I'm just going to type this equation in. So it's y equals 2 raised to the power of x. Oh, and I got that wrong. So that's 2 raised to the power of x. So it should look like this. And so there you can see what that graph actually kind of looks like. So reading your answer choices below, it says, for question 1, the equation above is linear because it creates a straight line. Well, obviously this is not a straight line. Exponential because it creates a curve-shaped figure. Well, it looks like a curve-shaped figure, but let's read the last answer choice. Or is quadratic because it creates a U-shaped figure. Now, lastly, you guys already know what makes a quadratic equation, so automatically we could eliminate answer choice C, and it's definitely not a straight line, so therefore it has to be answer choice B. All right, and question number 2, it says, does the graph have X-intercepts and Y-intercepts? Well, that's either yes or no, and as I can see here, yeah, I can already see one of them. So yes, it does. And then lastly, it says to list the X-intercepts and the Y-intercepts here if I do contain those. So as you can see, you don't really have, and I'm going to just kind of make this a little bit bigger so I can see. As you can see, it doesn't really cross the x-axis at all. It gets very close to it, but it doesn't cross the x-axis. So this particular equation doesn't have any x-intercepts. Okay, but I can see where it crosses the y-axis right here. So the y-intercept here would just be 1, or it crosses the y-axis at 1. All right, so that was just a little warm-up. All right, so today, of course, we're going to be looking at exponential equations. And so the basic form of the exponential equation is written in the form of y equals a times b to the x. Now, whereas the a value, okay, so that means that there is a number that's actually going to go, we're going to put in that place. But that a value cannot be equal to 0. And the b value tells us some interesting things, okay? So first of all, the b value cannot equal 0. And also, if my b value is greater than 1, then I'm going to call that a growth, okay? And we're going to talk a little bit about what do you mean by growth. And if my b value is less than 0, which means it has to be negative numbers, then we're going to call that a decay, all right? So what does a growth look like? Well, automatically we know that an exponential equation looks like a curve. We just figured that out. Okay, so if it's a growth, that means that this line, since I'm starting from here, and I always read a graph from right to left. So since I'm starting here on the right hand side, as I continue to go further and further, to the right, sorry, I'm starting left, more left of the graph, and as I continue to go further and further to the right, you can see that the graph is steadily increasing and rising, so we call that a growth. And on the other hand, whereas a decay, on the other hand, is as I go further and further to the right, you see that this graph is slowly coming down, and we call that a decay. Okay, so when a is equal to 0, Okay, I just want to show you guys this as I always do. What happens when A is equal to 0? Well, I just plug some numbers in for B and some numbers in for A. And so when I replace the number with 0 for A, look at what happens. You have this equation right here, y equals 0 to the x. And so this is not going to create a curved line. And let's see, I'm going to show you guys that it's not going to. So if I go y equals 0 raised to the power of x, well, you can see that the blue line here now is not a curved figure. It's just pretty much a straight line. So at that point, if a is 0, then this equation is no longer an exponential equation. Okay, because we know that exponential equations are a curve-shaped type of figure, as we've kind of already verified with the warm-up activity. All right, and well, what happens if I replace b with 0? Okay, so this is what happens. You get basically the same thing, and we know that this looks like the same equation that I have here, and so it's going to make a straight line. So therefore, the equation would no longer be exponential if a or b were 0. Okay, so let's move on. So now I want to talk a little bit about function notation. I'm going to just delete these graphs out of here. Okay, and for a lot of times, I think people are so confused about what function notation is. But I'm going to help you to understand that a little bit better using our Desmos calculator. Okay, so function notation. Now, as you can see, these two equations here are the same exact equations. The only difference is I have a y written here and I have f of x written here. Well, f of x and y basically means the same thing. The only difference between the two equations is that one equation is written in function notation, which is the equation below. This is how we write things in function notation, by using f of x, because it helps us with an input and an output. Okay, let me show you what I mean, or maybe refresh your memory a little bit. So, how do we use function notation? So we're always going to take a look at examples as we're as we're going through this information. So first of all, you see I have this equation, and this time I don't have y equals, but I have f of x equals. Okay, f of x equals this equation. Now I'm going to come over to Desmos because I want to type that in and show you that, well, it's not going to make a difference. So I'm going to put f, open parentheses, x, and I'm going to make that equal 4, open parentheses, 2. And I'm just using parentheses because parentheses means multiply, okay? And I'm going to raise that 2 to the power of x as shown below. So therefore, we can see this green graph that's created, and it's definitely exponential, okay, as we've already mentioned before. But you can also notice that me putting f of x does the same exact thing as if a y was there. And let me show you that. So what if I go and put y equals? Same equation, 4 and 2, and I'm going to raise that to the power of x. Okay, so as you can see, it creates the same exact equation because they are the same exact thing. The only difference is the green equation is written in function notation. Now, why is that important in mathematics? Okay, so I'm going to help you understand that. So, we're going to use this function notation to help us find f of 0. Okay, f of 0 says that now, as you see, well, what does this notation mean? She put f of 0. It's no longer f of x. Well, what this means is that when I substitute a 0 in for x, I want to know what's my y value. That's what this is saying. Okay, so therefore, using this equation right here, if I were to substitute a 0 into the equation everywhere I see an x, that equation would look like this. Okay, so this is f of 0. This is saying when X is 0, I want to find out what my Y would be. And so, of course, if I were to plug this in my calculator, I would get that f of x, or f of 0, is equal to 4. Let me show you what I mean. Okay, so as you can see now, I have my graphing calculator pulled up, and so I'm going to just cut this on, all right, because I want to show you guys how to do this both ways. So basically, this function notation just told me that everywhere I saw an x in the equation, I wanted to, or I needed to substitute a 0 in. So the only place I saw an x was here where the exponent was written of x, okay? So instead of writing that x there, I now replace that x with a 0. And I want to figure out my outcome. So on your TI-84 calculator, if I wanted to do this by hand, I could go 4, open parentheses, put my 2 in, close parentheses, and then this little caret here, I'm going to raise it up, and then I'm going to put a 0 there because I want that 0 to be the exponent. And then I'm going to hit enter. And as you can see, when I substituted the 0 in for x, my outcome was 4, which is why we have the 4 here. Okay, now, this says, okay, same thing. I want you to find f of 1. So that means that when x is 1, we're trying to find what our y value is. Okay, so everywhere in this equation now, where I see a 1, or where I see x, I'm going to replace that with a 1. So I'm going to do the same thing. I'm going to put 4 and 2, and this time I'm going to raise it to the first power, and then I hit enter. So I see that my value now is 8. So when this means that when x is 1, my y value is going to be 8. Okay, now I got to substitute 2 in. This means that when x is 2, this is what this is saying, and this is why it's important for function notation. When x is 2, what is my y? So everywhere I see an x, I'm going to put in a 2, and then I get my outcome, which in this case is 16. All right, now I want to know what is f of 3. That means when x is 3, what is y? I 3 instead, and so my outcome is 32. Lastly, I want to know f of 4. So this is saying when x is 4, what is my y? This time I substitute 4 in, and I get 64. So basically what we have created here for several different x values here, I have some y values. So instead of just leaving them like this so that it makes sense to me, I'm going to express those in a table. So the only thing I did was I came over here, and all these x values and all these y values, they relate to this equation right here. Okay, so this means that, let me pull Desmos back up. Okay, so you guys can see exactly what I'm talking about. Okay, so all of these x values and y values are basically on this function right here. Let me show you what I'm talking about. Okay, so I have Desmos pulled back up, and I have this function right here that we created, and so now we know a specific number of values. If I wanted to find other values, I could by substituting numbers in. So if I wanted to know, see what value would 5 would be, see what value would y be when x is 5, I could by just substituting 5 in for x. But since we have this equation right here that's already written there, in Desmos generates tables for you. And so basically all these numbers that we're creating fall on this graph right here. So if I were to go up and down this graph, okay, let me see if I can get a number like here. So as you can see, this point just happens to be our y-intercept. This tells me that for this function or this equation, when x is 0, my y is 4. So that means that this point should fall on this green line right here. That's what that means. Also, when x is 1, y should be 8. So that means 1/8 should also fall on this graph here. And let's see if we can find 1/8 somewhere here so I can show you. I think I kind of went past it. Oh, there we go. There it is. So, oh, okay, so there is 1/8. That's also on that graph. But so basically all of these points will fall somewhere on this line and not outside of this line. This is what that means. But I can have several different more values. And let me show you how to come up with that in Desmos. So in Desmos, if you put an equation in Desmos and you hit this little gear, and this is what it's going to look like at this point. But I want to click on a table. So I want to convert everything to a table. And as you can see here, I have a list of x values, and I also have a list of y values that are here. Some of the values kind of are shown on our table. So like we have 0 in common. So we got 0 and 4. We have 1 and 8. And we have 2 and 16. But on our table, we don't have -1 and 2. And we don't have -2 and 1. But we could if we substituted x values in to find what the y values was. But the neat thing about Desmos is that I can find any value on this graph and watch what happens. So I'm just going to arbitrarily pick a point. I'm just going to pick 3 because that's the next number. So when I plug in 3 for x, it automatically calculates the y value for me. So I don't have to do it. And then not only does it calculate, but as you can see, it's also highlighting those points that's on the table. So all the points that you put in that table in Desmos, it's going to highlight those points on the actual graph for you so that you won't have to like find them like I did. You can just very easily track them down. So all these points are on there. I could find out some more points. I could put in 4. And it'll give me, I can put in 5 and it'll give me the value. I can put in 6 and it'll give me the value. Okay, just something that I think is very interesting. Okay, so hopefully that made some sense. All right, so let's move on. So now what we want to consider also is that since we're this value right here that we're substituting in, which is our x value, we always refer to that as our input because we're inputting this to get something out. So I input a 0 to get an output of 4, okay? Which the output values are my y values. So input, I put in my x values, out, and then I get an output of my y values. So I input 1 into this equation and I got an output of 8. When I input 2, I got an output of 16. When I input 3, I got an output of 32. When I input 4, I got an output of 64. Okay. Also, if I wanted to continue to find more and more points on there, I could. Because as you can see, I've nowhere near covered all the points that's on this line. There are so many other points, but you don't have to. You just need to understand what this notation means and what it's telling you. Okay, so my input is 6 and I got an output of 256 on here. All right, so let's move on. So remember, your input is your x and your output is your y. All right, so now let's consider this. Given the same equation that we were dealing with, okay, we want to find the following. Now, this time, notice that I don't have an input. So what do you think this value is? If I say f of x is equal to this would be, that's right, your output value. So basically they're saying, I gave you what your y is, now I want you to find what the x value would be. So exactly, they're saying, what is x when y is 4? This is what this is saying. It's just written in function notation, just so that you understand. So in this case, we're still looking at the same function. If I graph this function in Desmos like I have, they're saying, well, when x is, I don't know, x is some number, I don't know what that number is, when y is 4, Well, I come over here. Okay, well, y is 4, and this time my x will be 0. So this saying f of x equals to this equation, okay? We don't have anything to input at this point. This means still we're looking for when x is, we are looking for x. It says what is x when y is 4, or when y should be 8. Okay, had to go back and fix that real quick. But when y is 8, okay, still, we're still talking about this function. All right, what is y, or what is x when y is 16? This is what this is saying. For this same function, okay, what is x when y is now 32? Still this same function, okay? What is x when y is, in this case, 64? Well, I come over here and all I have to do is just graph this function right here. So let me show you. Okay, we just graph this equation. So I'm going to say f of x equals 4, open parentheses, 2 raised to the power of x. Okay, because it's exponential. And I want to know what these values are. So I'm looking for what's value goes next to x when y is 4. What value goes next to x when y is 8? And so forth and so on. So if I'm not really sure, I can come over here to Desmos. I got the equation in. Now I'm going to switch to the table and I'm going to play with some numbers. So as you can see, they already populated some numbers in there for me. So I can answer some of those questions. So I see that automatically. Well, in this case, I'm looking in my output column and I see that when y is 4, x should be 0. Okay. I also see that when y is 8, my x should be 1. All right. I also see that when y is 16, my x should be 2. All right. Now, I don't really know, so I'm going to just keep counting. Let's see. No, I don't need. Oh, yeah, I do need 32. So when y is 32, I see that my x is 3. All right. What else do we got? Let's see if 4 gives us a, oh, great. When y is 64, my x is 4. So now, according to what they're asking, I just created a table that shows all these all these x values that they were looking for. Okay, according to the y values that they told me, and I could easily find them because I had the equation. And of course, given my output values this time, because that's what they gave me, my output values, I could very easily graph this equation to try to find my input values. Okay, it's pretty easy. Okay, so now what I would like for you guys to do is to stroll down to the U-Try, and I want you to get familiar with the function notation and using Desmos the graph and using your TI-84 calculator to help you with the U-Try. And tomorrow we're going to come back and look at this together.